EXP6 Fluid Mechanics. Chapter 11 Turbomachinery. We want to use the 32-inch pump, 32-inch pump as shown in the figure, the diagram of the discharge and the total head of the 32-inch pump, and also N is now to pump water at 60 degrees Fahrenheit from one reservoir to another, to reservoir, $100 higher to (60-inch) inner diameter pipe with friction factor F equals to 300. Find what will be operating point and efficiency. To what speed should the pump be changed to operate at the speed to operate at best efficient point? At first we can write the head of system HS Z second minus Z1 to reservoir, and the loose head due to friction HF. The velocities are 0 and also pressure change were neglected during simplification. Because of the equality of pressures, the head systems write as this expression. So HS, we have the elevations difference and knowing nothing about the velocity, the friction factor, the distance as pipe, and the pipe diameter. So we can write HS as a function of, if we consider Q, V on A, we can write the relation for after simplification Q square. In this relation, Q is in foot cube on second, but in the diagram we have the units for Q is gallon per minute multiplied to 1000. So we should convert this relation to appropriate so the Q is in foot cube on second. If we Q and gallon per minute, this is a relation and multiple to 1000. If we replace to the equation above, we can obtain a relation for the system head as a function of Q as our desired relation matched to the pump diagram. Q second. Let me show the diagram again in the next page. In this case, we have also a relation for Q from this diagram, which is A, for example, plus B, Q second, the first part is H. Now we have a relation for a system head. Q second. We have two types of solution. The first part of a graphical solution. Graphical solution, we had two diagrams. We can choose this diagram points. For example, we can plot a the diagram for the pump. For example, we have this diagram approximately. We can obtain the point data from this diagram and plot it in the some software, for example, MATLAB. Other software, the 0 point for Q, this is Q and H. We have also a relation here. At Q0 we have HS equals to 120. With plotting it in the same diagram, we can obtain the operating point, for example, at the intersection of two relations. This is HS, this is H pump. Now we have the H approximately equals to, if we plot it in the diagram and find the 0 point, with the Q equals to 50,000 gallon per minute feet. The next solution also is analytical. second. Theoretical solution, we should obtain the pump relation, which can approximate with the equation 2 order of Q equations, and we are also HS from the calculation. With making an equality, we can obtain Q square equals to this quantity, and Q is obtained likely this quantity. With the same, we can replace to each one of these equations and obtain the head of the operation point, the head of the pump. The next demand of the problem is the to what speed should the pump be changed. We have BEP, condition best efficiency point. From the non-dimensional coefficients, head non-dimensional coefficient, for example, we have N D second, CQ. C the discharge coefficient, head coefficient, H on N to D to HG. Have the relation for CH star. HS for pump, we have minus Q second for the head of pump. So HS star is where we have the maximum efficiency. HS star is CH star multiplied to N2D2 on G. CH star is for the centrifugal pump, so we can calculate N2D2 on G. For the current pump, we have the diameter calculating, we can obtain HS star is feet. And we now feel for this relation that H star proportional to N2, so we can write H star 1 on H star 2 have the relation for n1 on n2 square. So to our desire h star second or 2 n2 n1 square h star 1 h star 2 h star 1 n on square. Let me this quantity should be equals to this relation. This relation comes from this hs of the system plus q square. At the start point, q square is cq and d second, where the cq is star. We converting to this relation, we can obtain h s star also. With mechanical unity, the relation non-equality obtained n2 smaller than 0, thus it is impossible to work at BEP. Because this, let me show again. This relation, this quantity greater than this, so we have approximately 19 and 2 equals to minus 120. This is the end of this problem.